Okay, this is estimation and percent error. They give this right here in the book, this estimate. They ask you to estimate 416 times 1,763. So 400 times 2,000. We've just rounded them off to nice numbers that are easy to multiply. 400 times 2,000. 4 times 2 is 8. And I get that many zeros. So 8 with 5 zeros is 800,000. The actual number, you'd use a calculator, is 716,768. Clearly, the estimate is okay. It's not great, but it does give you this idea of, is my answer close? It's good to have an estimate because you can check, did I type it in right? Or did I type it in like a moron and hit a wrong key? I do that sometimes. So having an idea of an estimate is then a good idea. So here they say to subtract. I would say about zero point 0.8 minus 0.35 is 0.45. Then I'd use an exact and I'd use a calculator. They rounded a little more, they got zero point 0.5. The exact is 0.436. Um, and yes, this is in the ballpark, so you probably typed it into the calculator correct. Calculate the estimate for this. I would do 6 plus 6 is 12 divided by 4 is 3. It's going to be a little above 3 because you're dividing by something that's less than 4. Um, Doing it in actual with the calculator, you get 3.4, which, yep. Making connections. In physics, you can use estimation to compare orders of magnitude in various measurements. In this case, the values are rounded to the nearest power of 10. So 10, 100, 1,000. When we get to great grand measurements, like in space, to the nearest power of 10 gives you something pretty close. Okay. Percent error. This is an important formula. It's not a particularly hard formula. It is in your IB formula booklet. It is used a lot in various science classes. Your percent error is VA, which is the approximate value, and VE, um, VE is the exact value. So it's VA minus VE over VE. Absolute value, it's positive, multiplied by 100 to get a percent. Okay? Sometimes you'll see that as actual or experimental value goes in for A. Expected value, that's what is known. If you're doing a percent error on something on an experiment that has been done before or is known, or you're trying to calculate an atomic weight or mass, you'd compare what you get to the known one that's been done for years and agreed upon, and that would be the VE, the actual accepted value. It would be VE. Your experimental value would be VA. So here we have the two shorter sides using this in an IB context. The two shorter sides of a right triangle are shown to be 3.1 and 3.9. Calculate the estimated length of the hypotenuse. Um, I'd call that 3 and 4. 3 squared plus 4 squared equals 5 squared. 3, 4, 5 right triangle. So my estimate is 5. If I do the exact, I use the Pythagorean theorem with the actual numbers. So I'm just going to do the square root of 3.9 squared plus 3.1 squared. And I get 4.98. 982. I'm going to carry a few more. Calculate my percent error. My estimate was 5. This gives me 0.00361 or 0.361%. Your percent error should be a percent. Okay, one more example. The volume of a cone can be found using V equals pi over 3 r squared h, or 1/3 pi r squared h, where r is the radius of the base and h is the height. Use an integer approximation to find an estimate of the volume and then calculate the percent error for your estimate compared to the stated values. So my estimate is going to be pi over 3 times my radius estimate is 6. The approximate times my height is 5. 12 times 5 is 60 pi. V sub A equals 60 pi. V sub E again, I'm going to have to use a calculator to get this. Times 5.2. And it's not like using a calculator is that hard, but the estimates sometimes are a good tool for us. And I get 189.555. So my percent error, 60 pi minus 189.555 over 189.555. And that'll give me the decimal version of the percent error. I didn't put in an absolute value. I get a negative. I didn't use the absolute value thing on the calculator. I'm just absolute valuing it when I see it. So again, 0.559%. My estimate actually turns out to be pretty good. I think they gave you values in these that turn out to be really nice estimates. Okay, so that's estimating and percent error.